teacher!
Hey guys, this lesson is on exterior angles of polygons, and it's the second lesson in our geometry unit. It does have an exit slip that you're going to have to take a picture of and remember to watch on a faster speed, but it's a fairly simple concept to understand. So the first bit is about exterior angles of all triangles. So there's a lot of jargon that you should have learned from middle school about supplementary angles, parallel line theorems, transversals, and things like that. So this paragraph in the lesson might seem really complicated, but it's not actually too bad. The exterior angles of all triangles is simply the sum of the two opposite interior angles, just like this diagram shows. So A angle and the B angle put together make this opposite D angle. So if we were doing, for example, like this, and we wanted to figure out what this angle is, then this exterior angle would be the sum of the two opposite interior angles, which would be the C, sorry, not the outside, just the inside, and the B. So these two is the same as that. So in this example here, find the indicated unknown. We have an exterior angle of 115, and then the opposite two interior angles are these two. It's not this one because this one's right next to it. This would be a supplementary angle, and supplementary, in case you forgot, is straight line theorem. So if I had a straight line, all straight lines add up to 180 degrees. Even if I split it into 4 ways, I can add all these up and they'll get to 180. So if you wanted to find the U angle, you know that 115 is equal to 50 plus U, just like this property D is equal to V and U. And then you just do your solving equations, subtract 50 on both sides, and you should be really good at this now, where you don't need to show the balance method. You should be able to just do like this, like you're bringing it over to the other side and subtracting. So then the 115 minus 50 gives you your U value. So U is equal to 65 degrees. And that's my final answer. So it's fairly simple, but again, maybe the jargon seems complicated, but supplementary is talking about straight lines. It may be referred to as SAT sometimes as well, supplementary angle theorem. So in this second example, we're now going with variables, but it's the same thing. So 128 is my outside exterior angle. So 128 is equal to these two opposite interior angles that are added together. So 128 is equal to 3x plus this whole other angle. And it's technically proper form to put in brackets, but the brackets don't actually mean anything because we're just adding. So you would now combine what you learned in powers and polynomials, where you need to, collect the like terms. And so here we have the like term of 3x, and we also have the like term of 10x. Negative 2 is not a like term because it does not include the x. Remember, you have to have the same letter and the same degree. In this case, it's degree to the 1. So 3x plus 10x is the 13x. And then this minus 2 is going to be brought over to the other side by adding 2 so that these will cancel out. So then the 128 plus 2 will be 130 is equal to 13x. And then if I want to isolate for x, because I need to find what it is, I have to do the opposite, which is dividing by 13 on both sides. So 13 divided by 13 cancels out, and you're left with just x, and I'll write that on the left. And then 130 divided by 13 is 10. So x is equal to 10, but that's not my angle. So then I just have to do a bit of an extra step where U is equal to 3 times 10. So U is equal to 30 degrees, and that would be my final. And then V is equal to 10 times 10, because I'm substituting the X values that I solved. Oops, sorry. I'll pick a different color, like a green. Like this 10 comes here, and this 10 comes here for the X, and then I just do the math. So 10 times 10 is 100 minus 2, so V is 98 degrees, not the band, just the degree value. And then I'm done. So that's exterior angles of a triangle. The last thing that you need to know, it's also very simple. It's the opposite of what we learned in 6.1. We learned what the sum of interior angles are, and we followed this formula. You count the number of interior triangles, and that's where this n minus 2 came in, because all triangles had an internal angle sum of 180 degrees. So if you had a multiple shape, you can divide it into interior triangles. So here there's 3 triangles, but there's 5 sides. So 5 minus 2 is 3. That's the interior number of triangles times 180, and that gets you the inside. So here in this pentagon, my n value is 5. So technically it's 5 minus 2 times 180, which is 3 times 180, which is equal to 540. And because it told me that it is a regular pentagon, that means that every single side is the same length. And if every side is the same length, that also means that every angle is going to be the same. So I can take the 540 and divide it by 5 angles, and I will get my interior angles, which is 108 degrees. So the measure of each angle is 108 degrees. And then using my supplementary angle theorem of all straight lines have 180. So for example, I know that this is 100. Let me erase the red. So if I know that this is 108 degrees and the whole straight line is 180, that means that I can do 180 subtract 108, and I will get this B value. So B, for example, is equal to 180 minus 108, and that is equal to 72 degrees. And because all of the angles are the same, every single exterior angle is 72 degrees. And you'll notice that if I added up all of these A, B, C, D, E angles, 72 times 5 pretty much, times 5 angles, you'll see that the sum of the exterior angles is 360 degrees. And the reason for that is if you converged all of these and put them closer together, and I'm going to post some videos to show that, it makes a complete circle, and a circle is 360 degrees. So the sum of any exterior angle of any polygon is always going to be 360 degrees, which is why if a polygon has more sides, it starts looking more and more like a circle and more round because it's starting to converge. So here, for example, if you are given all of the angles on the outside except for one, you can solve for K by saying 360 degrees, and then you subtract all of these guys. And in this geometry unit, we're not so picky about like your solving equation form because a lot of them are really, really simple math. So don't worry too much about your form in this particular unit. But you subtract all of them, and then you pretty much have your K answer, and that would mental math, 81 degrees. So K is equal to 81 degrees. And that's it for this lesson. You can do the exit slip, take a photo of your work, and upload it to the classroom.